Okay, on this show video I thought about showing you how I actually bin these X48 LGA775 motherboards. When it comes to like serious 775 overclocking, you do have to actually bin these motherboards because they do vary a lot in performance and in overclocking capability, because the north bridge of the motherboard is almost like a second CPU in today's standards. The memory controller resides inside the north bridge of the motherboard, and the north bridge also determines how high frontside bus speed you can eventually reach, therefore affecting the maximum possible CPU overclock as well. And recently I have been obtaining quite a few X48 motherboards, and at the moment I have in total like 4 Rampage Extremes, 2 ASUS P5E3 Premiums, and 1 ASUS P5E64 Workstation Evolution. The Workstation Evolution is only for testing purposes, so I don't really use it for overclocking purposes. Some might be alright, but at least the one that I have is not like absolutely golden. It's somewhat okay, but it's not very good. But in this video we will be checking out the P5E3 Premium because it's actually a very good motherboard. Some of these can be as good as a very good Rampage Extreme, and even better than Rampage Extreme with some CPUs, especially with the Conroe CPUs, like the E6750 that I struggled with a lot when I ran it on LN2 on the Rampage Extreme. For that CPU you should be running a very good P5E3 Premium. So let's enter the BIOS by pressing F1 on our keyboard. I'm running the latest BIOS that the motherboard that's released for the motherboard, I mean, and I will just load the profile 1. So what I'm checking out is what kind of memory speeds the memory controller hub can actually run. I do not trust frontside bus binning on air cooling. I mean, when the CPU is running on air, I don't find it very consistent. So if I want to test the maximum FSP of a motherboard, I prefer doing that when the CPU is on LN2. So I just want to see how good the MCH of the motherboard's north bridge is, so how high memories it can run, like how high frequency with 200 strap, and can it even run all of the available straps, and like how high frequency with performance level 5 and 6 and so on. So the first thing you want to check is that can the motherboard run the 200 strap or even the 266 strap. I have one Rampage Extreme that can only do 333 and 400 MHz straps, and that's a very bad thing from the get-go already, because the most performing ones are the 200 and the 266 straps. So check these out first. If you can run these just fine, then you can of course try the higher frequencies with tighter performance levels. But I will be setting out 200 MHz strap, which is, well, in a way it's the most performing one, because this strap allows you to run the tightest possible performance level. So CPU multiplier of 9, 500 FSP, that means CPU overclock of 4.5 GHz, memory frequency 2000 MHz with this particular strap, command rate 1, 676, 21, 4, 72, 8 and 4. The sub timings can be left at auto for this part. They will be set to quite good values on their own, so I will just leave them at auto. Disabled on the static and dynamic read and write controls, skews all at auto, and the AI clock twister can be left at auto, so I will not set that one. But the AI transaction booster, I will set the performance level to 5, which is the most performing one you can ever run. If you run 266 MHz strap, the tightest performance level you can achieve is usually 6. So I will set these. CPU voltage, set that to the value the CPU needs, so I just set it to a safe value of 1.38. PLL to the lowest value of 1.5, that's the lowest one. VTT 1.4, DRAM according to the memory kit, so I will just set it to 1.9 for now. And now the important thing about the North Bridge voltage is that if you want to try the minimum voltage, or I mean if you want to try like 200 strap performance level 5 at 2000 megahertz with 676 timings or 675, doesn't matter. The tricky part about North Bridge voltage is that higher is not always better. Usually at this setting range you need to find the sweet spot voltage for the North Bridge voltage, I mean to be stable. For example, my best Rampage Extreme, the so-called Team Finland edition, it requires 1.43 North Bridge voltage for this particular configuration. If the North Bridge voltage is set higher than 1.5, like 1.5, 1.55 or even 1.6 plus, it will not even post. So it will not post and therefore it will not even boot to the operating system. If the North Bridge voltage is set at 1.43, it will post and boot just fine, and it will run 32M fully stable with performance level 5 and even stronger on the AI clock twister. So how I would recommend is that first try at 1.5 ish. If it's not stable, try to set lower value first before you go even higher, like 1.41 to 1.45. You should need at least 1.4, so I don't think there's need to go under 1.4, but definitely sometimes a lower value might be a lot more stable than a higher value on the North Bridge. So it's very tricky. You really have to play around with the North Bridge voltage. The North Bridge voltage affects the maximum memory the North Bridge can run and also the max FSP the North Bridge can hit. So the North Bridge voltage is the MCH voltage of the motherboard. So for now I will set this to 1.51. SP, I just set it to manually to this. I mean I just set it to the stock value manually. So the stock value is 1.05. Clock overcharging voltage I will leave at auto. Load line calibration at performance. Disable spread spectrums, and that's pretty much it. I have disabled all of the onboard devices for this particular use, and we can disable Vanderpool technology and execute disable bit. We don't need those. And you wanna disable the ASUS Express gate if you are doing any kind of serious testing on this particular motherboard. And I might actually try to disable the C1E because for some reason this particular motherboard reverts the CPU into some weird power saving mode. It drops the multiplier from the set 9 to value of 6. So let's F10 and save and exit these settings, and if we can post and boot these settings just fine, then we can try to run SuperPi 32M. Okay, so now I finally passed at 2000 megahertz, similar or same timing table pretty much, so 4.5 gigahertz on the CPU. In the first attempt I failed to post 1.51 volts on the North Bridge, and it's very weird because any North Bridge voltage less than 1.5 volts usually posts and even boots happily, although below 1.4 volts I could not boot to the operating system anymore, but it can still post. Now I actually finally passed the SuperPi 32M test with a North Bridge voltage of 1.53 to 1.55. So it's quite weird. So but I really don't like the 2000 megahertz profile because it's very tricky. Like what happens with the Rampage Extreme, as I said, needs 1.43. Higher than 1.45 and so on, doesn't even wanna post and boot anymore. So the maximum speeds are a lot more consistent than running stuff at this particular 2000 megahertz profile with performance level 5 or even 6, especially with performance level 5. But this is already a good sign that it can run all of the straps and even performance level 5 at this particular memory configuration. So now I will try 2100 plus with performance level 5 and 6. Usually you want a motherboard that can run performance level 5 and performance level 6 above 2100 megahertz, although it doesn't really matter anymore once you go beyond a certain point. Then the second factor comes in, that can you still run SuperPi 32M with very good memories at very high FSP. That's another thing, and it's very hard to test that on air cooling. Then so there are like three factors that come into play: the maximum FSP, the overall like memory controller hub quality, and does it still remain the quality at very high FSP. So but of course we can test what we can on air cooling and sort out most of the motherboards. So the other P5E3 Premium that I got already fails like performance level 5 at around like 2050 megahertz. So let's try to push this one to 2100 now. Okay, so I managed to pass 32M at 2100 with performance level 5. It's very on the edge though, so it is far from like 100% consistent passing, but it gets dramatically easier if I drop the frequency even like one increment lower. So definitely the max 2100 I mean, and I actually passed this twice, so 2100, 676, 2172 command rate 1, and can confirm the performance level 5 over here. So all of the sub timings are over here. I passed the same speed one time earlier, so over here. This one was like 1 second faster, but same timings, same speed, 2100, 676, performance level 5. So I think heat is one big issue. So I think the heatsink assembly is still with the original thermal paste that was applied to the motherboard 12 years ago when it came out to the market. So I am sure I could gain a few degrees if I swapped the thermal paste of the North Bridge and the South Bridge to something like KPX. So I will definitely do that after this. So 2100, and as I said, it becomes dramatically easier if I go even a tiny bit down on the frequency, but if I go even higher, like a few megahertz, it becomes so unstable. And for example, 2120 doesn't boot to the operating system anymore. So definitely the max, and it doesn't really move with North Bridge voltage. There's also one big like tricky thing about the North Bridge voltage. The NB voltage I used for this particular run was around 1.7 volts for both of these runs. But for some reason the motherboard doesn't want to post if I set 1.7 on the North Bridge straight away. It doesn't want to post. So I have to play it around so that I have to put something like 1.6 on the NB to post the settings, and then I have to go back to the BIOS, increase the North Bridge voltage to 1.7, F10 for one more time, then boot to the operating system and run the test. So I don't know what's the case about that, but that's how it goes. The maximum value on the North Bridge voltage you can generally use on ambient cooling. I mean, ambient cooling on the North Bridge is generally like 1.8. I would not go over 1.8 without cold temperatures on the North Bridge. So just saying. So based on what I have discussed with a few other members, many people consider like a good target. I mean, many people consider 2100 plus with performance level 6 as a good target. So performance level 5 is much harder to achieve than performance level 6. So I'm quite happy, and you don't really need much higher frequency than this, because as I already said, the key factor after this is that can it still run very good memories in SuperPi 32 and when the FSP is much higher, like 600 plus. So you don't really need more than 2150 memory wise, even with something like performance level 6. So this is definitely very good result and probably good enough already. So let's see what's the max with performance level 6. Okay, so managed to improve a little, although this is very on the edge. So I passed 32M at 2135. 2140 was very close all the time, like crashing at around like loop 22. Even like 2150, 2160, they all, many of those runs were like possible to go up to like loop 15 or even 20, 21, but then it fails. So I'm not sure, could it be like the Northbridge temperatures if they slowly start to creep up, because I'm sure the original heatsink assembly is still with the original like thermal pastes from 2008. So I should definitely swap those thermal pastes, because 12 years using the same thermal paste, that doesn't sound very good. So 4.5 something I think on the CPU. Damn, that power saving feature is annoying, but you can see, so 2135, 4.536 on the CPU. So let's check memset, performance level 6 and so on. So let's try to save this screen, but I think this is roughly the max. So I think this is very good. The best, what I already said, the best P5E3 Premium what I've seen has been at around like 2140 with performance level 6, something like that. I think that failed. Oh, it didn't. So yeah, 4536, 9 minutes 54.875 seconds. I will quickly try a little bit higher, but if I cannot get it stable, like to pass 32M, I think that's then I think it's time to wrap up this video. Okay, I think it's time to finally make a conclusion about my few days of extensive testing with the X48 motherboards. So this video was mostly about the ASUS P5E3 Premium, which is kind of new motherboard model to me, as I never really used it before that much. And it was also finally time to properly test the brand new Rampage Extreme from Japan, which I purchased using the buy.japan proxy website. The first one of the P5E3 Premiums was bought from the American eBay, and it did quite alright. It was able to do all of the available straps, and it did the very common 2000 MHz 675 memory configuration, even with performance level 5, with a Northbridge voltage of like 1.63. The maximum where it stopped, like memory wise, was at around like 2050 MHz, and it didn't really change much, no matter if the performance level was at 5 or 6. So it's quite an okay result, but it's not very like golden, like absolute golden. Now the second one of the boards was bought from Allegro.pl. It's a Polish eBay style website, and this particular board, which I'm also running at the moment, it was able to do the same 2000 MHz memory profile with 675 timings and performance level 5, with a Northbridge voltage of 1.55, 1.57 or so. The performance level 5 obviously requires the 200 MHz strap, so it's not possible with any of the other available straps. Now the tricky part about the P5E3 Premium is that it doesn't always want to post the required Northbridge voltage for the actual tests. So in this example, I had to, well, not always, but I often had to post much lower Northbridge voltage in order to be able to post, I mean. So like in this case 1.45 volts, and after the post process I had to go back to the BIOS, raise the Northbridge voltage up to the required level, so 1.55, 1.57, F10 again, then boot into the operating system and run the actual test. So that's one of the parts about this particular motherboard model that I don't like. I really don't see this behavior on the Rampage Extreme, but just saying. So this is quite good. So it's already a good sign that both of the boards were able to do all of the straps and this particular timing configuration or memory profile, even with performance level 5. The next step was the maximum frequency with performance level 5, and for this better P5E3 Premium, the frequency was somewhere around 2100 MHz. 676 timings in this case, but it doesn't really matter that much. That is the timing table 676 or 675. But this is not very consistent, so this is far from consistent result. So I really had to try a lot in order to pass this. So it really starts to get harder after 2050 megahertz, and this required very high north pitch voltage, around like 1.7. So roughly the same timing table as before, but just the maximum frequency for performance level 5. Now when it comes to the performance level 6, the maximum frequency was somewhere around 2133. So I was hoping for at least 2140, maybe 2160, but I think it's quite good. But the same thing happens even at this frequency level. So I had to post much lower north bridge voltage than what the actual test requires in order to run stable. So in this example I had to post or make the initial post with north bridge voltage of like 1.59, 1.61, then raise the north bridge voltage up to 1.71, 1.73, and boot into the operating system with that voltage and run the test. And there's also another thing about the P5E3 Premium, and that is that it actually overshoots the memory voltage as well as the north bridge voltage by quite a bit, and the jumpers are not enabled, so it cannot be that. The overshoot on those two voltage rails was around like 50 millivolts, so be cautious. So if you set 1.6 volts on the north bridge, the real value will be somewhere around like 1.65. So 2135, and I actually tried the maximum FSP as well, and I was able to do up to 640, 650, somewhere around that mark, and even SuperPi 32M stable at 600 FSP. So I think it's quite good, but I really don't trust the maximum FSP tests with CPU on air cooling, especially the maximum FSP or the maximum high FSP SuperPi 32M. You really have to put the CPU at least on cascade cooling to try that properly. But even well, I was able to boot into the OS at 650 FSP, so I think it's quite good result already. Then the most interesting part about the actual testing was with the brand new Rampage Extreme from Japan, and it was so awesome to see that there were no BIOS profiles in the BIOS at all. So that means that the motherboard was never truly overclocked. The thing with these particular motherboards is that if you flash the BIOS, no matter if it's the same BIOS version or another BIOS version, the BIOS profiles will not get removed or overwritten. So it's very likely that the motherboard was never really overclocked, and the board was able to do the same, well, roughly the same 2000 MHz memory configuration with performance level 5 with first attempt with only 1.45 volts on the north bridge. So very good result already on the first attempt, and the lowest north bridge voltage it's required for this particular configuration was only 1.41 to 1.43. That's extremely low value. It's roughly the same as my Team Finland edition. That one requires 1.43 volts on the north bridge for this particular timing configuration, so performance level 5 and the AI clock twister at stronger, so the maximum setting on that. And when I went up, like step by step, so the maximum frequency for performance level 5 was somewhere around like 2140. So here's a first screenshot at 2120, same timing table pretty much, so 67520, performance level 5 again, and the maximum was somewhere around like 2140 to 2150, but it's quite tricky, and you can see the reason over here. So for some reason this brand new Rampage Extreme, it doesn't like very high north bridge voltage when running this particular FSP to DRAM ratio at this FSP level. So this result was made with only 1.45 volts on the north bridge. So 2140 MHz on the memory, 67520, performance level 5, at only 1.45 volts on the north bridge. My best Rampage Extreme, it requires I think 1.63 for this same result. So I'm pretty sure this is the lowest north bridge voltage ever for this particular frequency and timings. The maximum is somewhere around like 2140, 2150. I have to play it. I have to play with this a little bit more later to see if I could go even higher. If I could run higher north bridge voltages like consistently at this frequency level and timings, the memory should go up to 2200 MHz and even beyond. Then I tried like high FSP SuperPi 32M. I made one very quick screenshot at 600 FSP, and at the higher frontside bus speeds the north bridge voltage actually scales and works like it should. The maximum like high FSP SuperPi 32M I was briefly able to do, that was at around like 640 FSP, but then I really hit the CPU FSP limit. So I really don't trust the high FSP SuperPi 32Ms on air on these Wolfdale CPUs. I really have to put the CPU on LN2 to properly test that out. But 640 FSP was the maximum I was able to do, but just didn't take the screenshot, but it's somewhere around that mark. And for that speed as well as for this FSP, the north bridge usually like to be at around like 1.55 to 1.63. So definitely an amazing motherboard. Really awesome Rampage Extreme. So it's much better than the one I showed you on the overview video. So I'm definitely happy that I purchased the Rampage Extreme from Japan, and it wasn't that expensive, although it ended up being quite expensive due to the shipping cost as well as the value-added tax at the customs. But yeah, so these are the steps I would do if you want to bin these X48 motherboards. So the maximum memory is the most important first. So test the different straps, test the performance levels, like the maximum frequency for performance level 5 and 6, and then you can test the FSP and so on. But you really need a very good kit of LP to hyper-based DDR3 memories. I wouldn't use power chip based memories or any other DDR3 IC standard. Use LP to hypers, they are the better ones for sure, or the best ones. So for this run I used one Dominator GT 1866 Cas7 stick and one 2000 Cas7 stick. So Dominator GT is very good, Super Talent is very good, A-Data 2200 Cas8 is very good. Some of the G-Skill Perfect Storms can be quite good. And there are a few other ones as well, but yeah. So I hope you like to see this video, so definitely use these steps if you like these older platforms like 775, overclocking and so on, and subscribe to my channel for more videos like this. And thanks for watching once again, and I will see you on the next one.